All right, folks, want to welcome you back to Unit 3. This is Part 3, the quantum model of the atom. In our last video, we took a look at the physics of waves because, as it turns out, electrons have wave-like tendencies. They have wave-like characteristics. But they also, of course, have particle-like characteristics. And so we want to turn our attention back today to the electron as a particle. So here we go. In the early part of the last century, Erwin Schrödinger, using these complex mathematical equations, showed that electrons existed only in specific locations around the nucleus. Just as Bohr had described the specific main energy levels, so did Schrödinger. Now, there are 7 main energy levels around or shells which are arranged in concentric spheres around the nucleus. So let's take a look at this model. So we've got in the center of the nucleus, of course, of the atom, of course, the nucleus. And here it is right here, the nucleus in the center of the atom. But around the nucleus, Schrödinger said that there were these areas, these concentric spheres that electrons could reside in. And they couldn't reside anywhere else other than in those areas. So the first one was the lowest energy level. We'll call that n equal 1. The last one is called n equals 7. And it is the highest in energy. So as electrons move further and further away from the nucleus, their energy increases. So electrons further away from the nucleus have a high energy. As they fall closer to the nucleus, their energy decreases. Now you have to really concentrate now on what's happening within each level. Within each main energy level, there are one or more sublevels. So within a main energy level, and remember there's 7, there's one or more sublevels. These are designated S, P, D, and F. So within the main energy levels, there are sublevels, and we call them S, P, D, and F. Now, not every main energy level has all those sublevels, however. The sublevel, or the S sublevel, is spherical, right? It looks like a sphere, like this one right here, or this one right here. The P sublevel is dumbbell shaped. Dumbbells are weights, like if you're in a gym, they're two-sided weights, and we might draw it like this, or we might draw it like this, or we might draw it like this. But they have 2 areas of mass, right? 2 areas of substance on the left and the right, or top or bottom, or however you want to look at that. But that's what we call a dumbbell. The D sublevel is double dumbbell. So a double dumbbell might look like this. So a double dumbbell will have a left and a right and an up and a bottom. So that would be a double dumbbell. So that's D sublevel. And the F sublevel is flower shaped. It's just too complicated to draw on a 2-dimensional sheet. So I'll just leave that one to your imagination. But it's more complicated than the S, the P, or the D sublevels. So there you have it. S is spherical, P dumbbell, D double dumbbell, and F is flower shaped. Now, within each of these sublevels, so we're really talking about levels within levels. Within each sublevel are one or more orbitals, what Schrödinger described as orbitals. There is one orbital in the S sublevel, and it's simply called the S orbital. There are 3 orbitals in the P sublevel, and we call them P sub x, P sub y, and P sub z, right? P sub x, P sub y, and P sub z. There are 5 orbitals in the D sublevel, and there are 7 orbitals in the F sublevel. So let's go over all of this again. There are 7 main energy levels, okay? Within the first main energy level, there is one sublevel. It's called the S sublevel. Within the second main energy level, there are 2 sublevel types. They're called S and P. Within the third sublevel, there are 3 sublevel types. They're called S, P, and D. And within the 4th sublevel, or 4th main energy level, there are 4 sublevels, and we call those S, P, D, and F. And we won't worry about the 5th, 6th, and 7th because they're much more complicated, right? But there you have it. Now, there's one orbital in the s sublevel. We call it S. There are 3 orbitals in the p sublevel, p sub x, p sub y, and p sub z. There are 5 orbitals in the d sublevel, and there are 7 orbitals in the f sublevel. So each orbital can have a maximum of 2 electrons within it. That's a rule. Each orbital can have a maximum of 2 electrons in it. So if I were to ask you how many electrons are in a p sublevel, you would say, well, a p sublevel, I was told by my teacher, has 3 orbitals, and each of those orbitals can hold 2 electrons. 2 times 3, 6 electrons. Okay? So that's how that works. All right, let's move on. So in the first main energy level, again, this is just a recap. In the first main energy level, there's one sublevel. We call it S. Second main energy level, there are 2 sublevels. We'll call them S and P. In the third main energy level, there are 3 sublevels. We're going to call those S, P, and D. And in the fourth main energy level, 4 sublevels. We'll call them S, P, D, and F. All right? So now let's think of a single electron. Where can it be? Well, according to Bohr and then Schrodinger, it can't just be anywhere. There are a finite number of places that electron could be. For example, it could be in the py orbital of a p sublevel of the third main energy level. That's one place it could be. Or it might be in one of the 7 orbitals of the f sublevel of the fourth main energy level. But there are a finite number of places that it can be. Now, we want to talk now about something called quantum numbers. Just as everyone has an address, every electron has an address. Just as you have an address and I have an address, every electron has an address. So to locate someone, you need to know their country, their state, then their city, and finally, the street address. If you want to find somebody, you're going to need all that information. In the same way, a set of 4 numbers called quantum numbers describes the location of electrons or an electron. The first one is called the principal quantum number, and we use the letter little n to describe the principal quantum number. Now this tells us the main energy level. So if you want to know the address, the main energy level or the principal quantum number is the letter n, and it tells you the main energy level. The principal quantum number can range from 1 to 7, we've said that, but we'll focus on the first 4 shells. Possible values then are 1, 2, 3, 4, 5, 6, and 7. So 7 possible values of n. N could be any of those. Those are the principal quantum numbers. Those correspond to the main energy levels that an electron can reside in. All right, the next one is called the azimuthal quantum number, and we use the letter L to designate that. This tells us the subshell type. The subshell type. So once we know the main energy level, we want to know the type of subshell that the electron resides in within that main energy level. It could be 0, which corresponds to an S subshell, or 1, corresponding to a P subshell, or 2, corresponding to a D subshell, or finally 3, corresponding to an F subshell. So possible values then are anything up to n minus 1. For example, let's just say that n is equal to 3. The possible values of L are, if n is equal to 3, 0, 1, and 2. And these correspond to S, P, and D subshells. In other words, if n is equal to 3, then the electron could be in an S, a P, or a D subshell. So the higher the main energy level, the more possible sublevels that the electron could reside in. All right, now, let's move on. The next number, the third quantum number, is the magnetic quantum number, or little m. This tells us the specific orbital within the subshell. So possible values are anything from plus to minus L. For example, if L is equal to 2, m could be minus 2, minus 1, or 0, or plus 1, or plus 2. These numbers correspond to the 5 orbitals of a D subshell. So there's 5 numbers here, so 5 orbitals of a D subshell. -2, -1, 0, +1, or +2. So that's the third piece of information, the magnetic quantum number. And the final one, the spin number. This tells us the spin of the electron. There are only two possible values, +1/2 or -1/2. If two electrons reside in the same orbital, they must have opposite spins. One will be +1/2 and the other will be -1/2. So that's it. There are four quantum numbers, so let's say that an electron has the following four quantum numbers. 1, 0, 0, +1/2. What does that mean? Here's what we know. It's in the first main energy level. That's because of the 1. It's in the S subshell because L is equal to 0, right? And 0 corresponds to an S subshell. And there's only one S orbital, n equals 0, right? So there's only one of them. And the spin on the electron is in the +1/2 direction, all right? The +1/2 direction. So that's it. That tells us everything we can know about that electron. No other electron can have the same four quantum numbers. That is the address for that electron, and no other electron can live there. Now, specific rules govern how electrons fill in around the nucleus of the atom. There's two in particular. They are called the Aufbau Principle. The Aufbau Principle, and it states that the electrons fill the lowest possible energy levels possible. So when the electrons are filling, they have to fill from the lowest energy possible. For example, for a specific main energy level, an electron will move into an s orbital before it moves into a p orbital, since the order of energy states from lowest to highest is s, p, d, and f. So an s is lower than p, is lower than d, then lower than f. So S's will fill first, then P, then D, then F. And secondly, the Pauli exclusion principle. And the Pauli exclusion principle says that no two electrons in the same atom can have the same four quantum numbers. In other words, there can't be more than one electron residing at an address. So that's called the Pauli exclusion principle. All right? I think that'll do it for this one. We'll see you on the next one. Thanks. Bye-bye.